Hi, myself Krishna Reddy. I welcome you all for ACE online platform. Faculty of Electrical Engineering, subject is Power Systems. Now, let us try to analyze some key points regarding underground cable for your SSC JE preparation. So, if we observe how many ways the power transmission can be done. So, the power transmission can be done mainly in two ways. One is using overhead transmission line. Overhead transmission line. In most of the cases, we do the power transmission using overhead transmission line. And the second one is we can also transmit the power using underground cable. So, these are the two modes of power transmission we can say. One is using overhead transmission line and the other one is by using underground cable. Today's our topic is going to be the underground cables. Now, if we observe the overhead transmission line, it consists of what? So, by observing this diagram, what we can say, overhead transmission line consists of what? There will be a line supporter will be there, that is tower, and cross arms are connected to that, and insulator will be there, conductor will be there. Okay. So, if you observe the overhead transmission line, it consists of line supporter, cross arm, insulator and conductor. So, these are the elements that we have in case of overhead transmission line. This is a tower or line supporter, and here we have the cross arm to which insulator is attached, and we have the conductor. So, its construction looks simple. Okay, construction of overhead transmission line. By observing this, what we can say, it is simple in construction, simple, and cost is also less, because here the insulation is required only at the line supporter. Okay, remaining areas air will be acting as the insulator. Okay. Now, coming to the underground cable. If you observe the underground cable, it consists of what? Conductor, there will be a conductor. Over this conductor surface, insulation is required, and here the insulation is required throughout the length of the line. So, the cost of insulation will be more because the cable is laid under the ground. Okay. And over that we have the sheet, metallic sheet we can say, bedding will be there, armoring and serving. So, underground cable consists of what? Here we have the conductor, over the surface of conductor we have insulation, over the surface of insulation we have metallic sheet, over the metallic sheet we have bedding, over that we have armoring, over that we have serving. Okay. These are the things that we going to have in case of underground cable. So, what is your observation? By observing these points, so elements in case of underground cable, its construction looks complex. And cost will be also high. Because the insulation is required throughout the length of the line, cost will be also high. Now, let us look at the details of underground cable, that is conductor, insulation purpose, sheet, bedding, armoring and serving. One by one, let us try to observe here. Now, if we observe the core, or we can also call it as conductor, core or conductor. What is the purpose of core or conductor in case of underground cable? To transmit the power or to carry the current. to carry current, we can say, or to transmit power, to carry the current or to transmit the power, we need what? Core or conductor is required. Here it is a solid conductor or a stranded conductor if the question goes like that. This is a stranded conductor. Stranded conductor. It can be either of aluminium or copper. In special cases we go for copper because generally it will be of aluminium only. So it can be either aluminium or copper. Indicated as underground cable UGC X by Y. X indicates number of strands. X indicates what? Number of strands. Y indicates diameter of the strand. Okay. So this is about core or conductor. Its purpose is to carry the current or transmit the power. This is nothing but the core. Okay. It is of stranded conductor indicated as what? UGC X by Y. X indicates number of strands, Y indicates the diameter. Now let us go for, over the conductor surface we have insulation. What is the requirement of insulation? Why the insulator is required or insulation is required here? The purpose of insulation is to avoid leakage current to ground. Okay? To avoid leakage current to ground. So to avoid leakage current to ground, insulation is required. Okay. So over the surface of conductor we have the insulation. Okay. So now what are the properties of insulator we need? Okay, what are the properties of insulator that are being required in case of underground cable? It should have high dielectric strength. The insulating material that is to be used should have high dielectric strength. If you are using low dielectric strength, automatically the size of the cable will grow. Okay, to avoid that we prefer to go with what? High dielectric strength. And it should have high insulation resistance because it should not allow any leakage current. So insulation resistance should be high and it should not absorb any moisture content. It should be non-hygroscopic in nature. It should not absorb any moisture content and it should be free from impurities. These are some of the properties that the insulating material should have: high dielectric strength, high insulation resistance, non-hygroscopic and free from impurities. So what are the insulating materials that are being used in case of underground cable? One is vulcanized rubber, that is nothing but rubber treated with sulfur is known as what? Vulcanized rubber. And impregnated paper, that is oil immersed paper we can say here. So generally these are used up to 11 kV. Up to 11 kV we will be using this vulcanized rubber and impregnated paper. PVC is used up to 33 kV and 66 kV and above. 66 kV and above we will be using polythene. Okay. These are the insulating materials that are being used in case of what? Underground cables. So now over this insulation we have the metallic sheet. What is the purpose of metallic sheet? Here the cable is laid under the ground. So here the purpose of the metallic sheet is to prevent the entry of moisture into the insulating material. Okay? To prevent the entry of moisture to the insulating material, we will be using the metallic sheet. It is of aluminum foil or lead foil. Foil means it will be in the form of a paper. So aluminum or lead foil. And here let us observe the questions. These type of questions can be asked in examinations. Sheets are used in cables. What is the purpose of sheets? That's what the question here. Provide a proper insulation, provide mechanical strength, prevent ingress of moisture, none of the above. So here the option stands with C. So the purpose of the sheets that are used in cables is to prevent the ingress of moisture, we can say. Okay. So these type of short questions can be asked in PSUs. So now let us go for bedding. What is its purpose? So it is nothing but a low grade insulator, just like a jute or hissant tape. Okay. So what is the purpose? Its purpose is to protect the metallic sheet from corrosion or any mechanical injury due to armoring. Okay. So to avoid the mechanical stress, we can say, it will reduce the stress, we can say. Okay. It is of jute or hissant tape. Okay. Now, if you observe, the question can be asked like this. The bedding on cable consists of what? So here jute strands, hissant tape, paper tape compounded with fibrous material, any of the above. Okay. Now coming to the armoring. So over this bedding we have the armoring. What is the purpose of armoring? Its purpose is to avoid the mechanical damage, because the cable is laid under the ground. While transportation and laying of the cable should not get damaged. So here its purpose is to protect the cable from mechanical injury while laying and handling the cable. Okay. So this is made up of what? Galvanized steel foil or steel tape. Okay. So the material used for armoring of an underground cable is R. Galvanized steel wire or steel tape, aluminum wire, A or B. So option is what? A or B. It can be either galvanized steel wire or steel tape, we can say. So over that we have the serving. So what is the purpose of serving? To protect the armoring from atmospheric conditions. It may result in corrosion. To avoid corrosion also, we can use this serving. So to avoid the corrosion, we will be using this serving. It is made up of fibrous material. It is made up of what? Fibrous material. So all these are what? The constructional view of underground cable, we can say. So here we have observed the cable consists of conductor. Over the conductor surface we have insulation. Over the insulation surface we have metallic sheet. Over that we have bedding. Over that we have armoring and serving. So we have seen a brief overview of all the elements that we have in case of underground cable. By observing all this, we can say that the construction of underground cable is complex and cost will be also more, because the insulation is required throughout the length. But there are certain applications where we need underground cable. Now let us look at the advantages and disadvantages of this underground cable, and then we go for the applications. So underground cable advantages and disadvantages. First let us look at the disadvantages. So here the area of cross section of the conductor of cable will be larger when compared to what? Overhead transmission line. Okay, for the same power, if you compare, the area of cross section of the conductor will be larger in underground cable when compared to what? Overhead transmission line. Once the area of cross section of the conductor is large, then automatically the cost of conductor will be more. So conductor cost is high. And the second one is, here the insulation is required for entire length, so which also increases the insulation cost. Conductor cost is more. Second effect is insulation is required throughout the length, so insulation cost is also high. One more drawback is, here the conductors are spaced very close, so the capacitance effect will be high. Okay, so the capacitance effect is high or low in underground cables? It is high, because the conductors are closely spaced. So if the capacitance effect is high, the charging current drawn will be more, so the cable may experience over voltages and it may result in damage. That's why the length of the cable is limited to what? 50 kilometers. Okay, this is one more drawback. So first one is, the area of cross section of the conductor is more, that means the conductor required is more, cost of the conductor will be high. The second drawback is insulation required is more, cost of insulation will be high. Third one is capacitance effect is high, charging current drawn will be more, so the cable may experience over voltages, and that's why the length is limited to what? 50 kilometers. And one more drawback is cable is laid under the ground. Identification of fault location is difficult. Okay, identification of fault location is difficult. All these are what? Drawbacks, or we can say disadvantages. Okay, but there are advantages also, because as the cable is laid under the ground, the occurrence of faults is less and no maintenance cost is there. Once the cable is laid under the ground, we don't require any maintenance activity on that, as we do the maintenance activity in case of overhead line. But there is no maintenance in case of what? Underground cable. And the occurrence of faults is also less. These are the advantages of cables. Okay. Now, let us go for the applications of underground cables. Where to use these underground cables? So, high densely populated areas, we prefer to go with underground cables, so that the area is electrically safe. So, there is no chance of electric shocks experienced by the persons. So, electrically safe is required. So, highly dense populated areas, in distribution network, we prefer to go with underground cables. And if you observe the overhead transmission line, it is terminated into the substation to the transformer using underground cable. So, here we have overhead transmission line. Now, it is terminated into the substation and it is connected to the transformer using a cable, because this cable capacitance effect is high. It acts as surge absorber. Okay, it reduces the steepness of the traveling wave. So, underground cable is overhead transmission line is terminated into a substation. The cable, by using the cable, it is connected to a transformer, so that it acts as what? Surge absorber. Okay, so cable acts as surge absorber. And one more application is when there is a road crossing or railway crossing. Specifically, whenever there is a railway crossing, overhead transmission line is terminated into underground cable and again reconnected after the railway crossing. Okay, railway crossings are important. And in submarine applications, we will not use the bare conductors. So, definitely we need to use what? Underground cables. These are some of the applications of what? Underground cables. Now, let us try to see how the cables can be classified. So, based on operating voltage, insulating material, based on number of cores. On these aspects, how can we classify the cables? Based on operating voltage, we have low voltage cables up to 1 kV, HV high voltage 11 kV, super voltage 22 to 33 kV, extra high voltage 66 kV up to 66 kV, extra super voltage, that is 132 kV and above. So, this is a classification based on what? Operating voltage. Based on the insulating material that is being used, vulcanized rubber, we can say vulcanized rubber treated with sulfur, impregnated paper, PVC and polythene. These are the insulating materials that are being used in case of underground cables. And based on the number of cores, here observe here, we have single core cables, 3 core cables, 3.5 core cables. Single core cables for 66 kV and above, we prefer to go with what? Single core cables. This is single core cable. This is a single core cable. There will be only one core. And this is 3 core cable. And this is 3.5 core cable. 3.5 core cable. Okay. So here in 3.5 core cable, area of cross section of the neutral conductor is half of the area of cross section of the phase conductor, because neutral conductor will not carry the current during normal condition. This is sometimes asked in PSUs. Area of cross section of the neutral conductor is half of the area of cross section of the phase conductor. Okay. So, 3.5 core cables are used in LV distribution. So transmission, we prefer to use single core cables because as the operating voltage increases, the thickness of insulation required will be more, so the size of the cable will be large. So to avoid that, we go for what? Single core cables. So now let us try to calculate the insulation resistance of single core cable. How do we calculate the insulation resistance? So if we observe an underground cable, this is a conductor or core of radius small r. Over this surface of the conductor we have the insulation. Over the insulation surface we have the sheet. This sheet is at ground potential. Sheet is at ground potential and overall radius of the cable is capital R. Now how do we calculate the insulation resistance? This insulation resistance, how do we calculate? Insulation resistance. How can we calculate the insulation resistance? So now let us calculate the insulation resistance by considering a segment of dx of thickness dx if you consider here. So first let us calculate the insulation resistance of this segment dx. So how do you calculate dr in the insulation resistance of the rho by 2 pi x into L into dx, rho by 2 pi x into L into dx. So this insulation is from the surface of the conductor to the sheet. So overall insulation resistance, how do you calculate overall insulation resistance? Small r to capital R, if you integrate this one dr in, that is rho by 2 pi x into L into dx. So overall insulation resistance is equal to rho by 2 pi into L into ln of capital R by small r. Okay, insulation resistance will be in the order of what? Mega ohms. Rho by 2 pi L ln of capital R by small r. Now, what is your observation? Here the important point goes like this. The insulation resistance of underground cable is inversely proportional to what? Length of the cable. As the length of the underground cable increases, the insulation resistance will reduce, whereas the conductor resistance increases. Okay. So what point we can make here? With increase in length of underground cable. So if the cable length is increase in length of underground cable, insulation resistance decreases. Insulation resistance decreases. Okay. Very important point. Based on this, the questions can be asked like this. Based on this, the questions can be framed. For example, if you consider length is 10 kilometers, length is 10 kilometers. The insulation resistance is suppose 20 mega ohms. If the cable length is underground cable, length is 10 kilometers, insulation resistance is 20 mega ohms. Suppose if the length becomes 20 kilometers, what will be the insulation resistance here? So insulation resistance is inversely proportional to what? Length. So what happens here? The insulation resistance in this case, here as the length is doubled, insulation resistance will be halved, 10 mega ohms. Okay, because insulation resistance is inversely proportional to what? Length. Whereas the conductor resistance will be directly proportional to what? Length. Why it so happens here? This insulation resistance, if you observe, suppose this is the conductor resistance, this is the conductor resistance, and here this is the conductor resistance, and here we have the insulation resistance. Now initially we have this length cable. Now to this, if a length is being extended, now if you are going for increase in length, then conductor resistance will be in series. Conductor resistance will be added up in series, but insulation resistance will be in parallel. So the effective insulation resistance will get reduced once the length of the cable is increased, but conductor resistance increases, we can say. Okay. So that's about the conductor resistance and insulation resistance. Very important objective point. Insulation resistance is inversely proportional to what? Length of the cable. Now let us try to observe the electrostatic stress in case of a single core cable. So how the electrostatic stress will vary? Let us observe here. Now consider the conductor radius smaller. Over this we have the insulation, and over that we have the sheet. So overall radius of the cable is capital R. Overall radius of the cable is capital R. Now let us try to observe, let us try to calculate the electrostatic stress at a point K, okay, at a point K which is at a distance of x from the center. Now how do you calculate the electrostatic stress at point K which is at a distance of x? Ex can be calculated as. So if it is electrostatic charge is lambda and the cable is operating with an voltage of V. So Ex can be written as lambda by 2 pi epsilon into x, lambda by 2 pi epsilon into x, okay, which is at a distance of x. But generally we prefer to express the value in terms of voltage rather than charge. So how do you write the value of operating voltage here? V can be written as minus of small r to capital R. This sheet is at a potential of ground potential, conductor is at V potential. Minus of integral capital R to small r Ex dx, Ex dx. So from this V can be written as operating voltage V is small r to capital R. Ex value is what? Lambda by 2 pi epsilon into x into dx. So here the operating voltage V is equal to lambda by 2 pi epsilon, lambda by 2 pi epsilon ln of capital R by small r, ln of capital R by small r. Here we require the expression for lambda. Lambda value can be written as what here? Lambda value can be written as V into 2 pi epsilon by V lambda V into 2 pi epsilon by ln of capital R by small r. So this is the electrostatic charge lambda. Now here we require the electrostatic stress, that is lambda value is what? Lambda by 2 pi epsilon into x. Lambda value is what? V into 2 pi epsilon by ln of capital R by small r, that is 2 pi epsilon into x. So electrostatic stress at point K which is at a distance of x is given by what? V by x ln of capital R by small r. So now by using this relation we can calculate where the maximum stress will be there and where the minimum stress will be there. Electrostatic stress is maximum at the surface of the conductor because it is operating at voltage of V, and electrostatic stress is minimum at the sheet because sheet is at ground potential. So when x is equal to R you will get maximum stress relation, smaller when x equal to capital R you will get the minimum stress relation. Okay. So what we can write here? So here we got the electrostatic stress Ex value as V by x into ln of capital R by small r. So here if you substitute x equal to small r, that is at the conductor surface, we get the maximum stress. At the surface of the conductor you will get the maximum stress, that is nothing but V by R ln of capital R by small r. And at the sheet, you will get the minimum stress, x equal to capital R. You will get the minimum stress, that is V by capital R ln of capital R by small r. So, this is a maximum stress will be at conductor surface. Maximum stress will be at conductor surface and minimum stress will be at the sheet. Minimum stress will be observed at what? Sheet. Maximum stress is at the conductor surface and minimum stress is at sheet. So, here the difference between E maximum and E minimum should be less so that the insulation material is subjected to less electrostatic stress. If the difference between E maximum and E minimum is more, the insulating material will subject to more stress and the life of the cable will be reduced. So, the difference between E maximum and E minimum should be less. Difference between E maximum comma E minimum is to be less. So, the difference between E maximum and E minimum should be less. So, the life of the cable will be more. If the difference is more, then the life of the cable will be less. The difference between E maximum and E minimum should be less or more. It should be less. Now, so how do you reduce the difference? How do you get the most economical size in case of underground cable? So, if the difference between E maximum and E minimum should be less means either you should increase E minimum or decrease E maximum. Decreasing E maximum is preferred, okay. So, E maximum value is what? Maximum stress is to be reduced. V by R ln of capital R by small r. So, E maximum should be low. E maximum should be less or it should be minimum. Maximum stress should be less. So, how do you reduce E maximum? How to reduce E maximum? How to reduce E maximum? How to reduce E maximum? That is a question here. So, how to reduce E maximum? You can reduce operating voltage. But if the operating voltage is reduced, power handling capacity is reduced. That is why this is not preferred. Only the way is to maximize the denominator. If you can increase the denominator, maximum stress will be reduced, okay. So, that means R into ln of capital R by small r should be increased. So, if you decrease the operating voltage, no doubt the maximum stress reduces, but the power handling capacity gets reduced, okay. So, maximizing the denominator is preferred. Now, this is function of R, that is R into ln of capital R by small r. So, now how do you maximize this differentiate with respect to variable dfr by dr and equate to what? 0. This is in the form of uv, okay, uv. So, u dash into ln of capital R by small r plus r into ln of r is 1 by capital R by small r into, so differential of that minus r by r square, okay, is equal to 0. R and r will get cancelled out, r square will get cancelled out, r and r will get cancelled out. Ln of capital R by small r is equal to what? Ln of capital R by small r is equal to 1. You will get capital R by small r is equal to E, or small r by capital R is equal to 1 by E. So, this is a condition for most economical size of the cable, okay. So, most economical size of the cable, or the condition for this, the condition for achieving the most economical size of the cable is capital R by small r is equal to E, or small r by capital R is equal to 1 by E. This is 2.71 something, this is 0.369, okay. So if you operate at that condition, you will get the maximum stress will be less. So if you observe the variation of maximum stress with small r by capital R, so it shows this is in the form of this. So when small r by capital R is equal to 1 by E, you will get the minimum maximum stress, that E max will be less. So, but if you observe, if you are operating at this point, it is in a critically stable state. This is in a stable condition and this is unstable point, okay. So at this point A, the system is under critically stable state. Now the question goes like this: if you operate at other than this maximum stress at this point A, or sorry, at this point B or C or E. Now the condition goes like this. For design, same design of the underground cable, for stable operation of the cable. So here we should design the cable when small r by capital R less than 1 by E, or when small r by capital R greater than 1 by E. At what point we need to design the cable? Here we need to design the cable to operate at small r by capital R less than 1 by E. Because one of the main reason for failure of underground cable is formation of void. Even if the void formation takes place, still it will be in stable region. There is a stable region of operation here. There will be a stable region. Instead of that, if you are operating at this point, it will be in critically stable state initially. It will result in unstable operation. That's why for stable operating region, so for stable operation, at design stage, small r by capital R should be less than 1 by E. So this is at design stage. At the design stage, we desire to maintain that, okay. And most economical size of the cable you can get by using this. Capital R by small r is equal to E, or small r by capital R is equal to 1 by E. For stable operation, we will maintain this condition, small r by capital R less than 1 by E, okay. So this is how we can calculate the electrostatic stress. Here the important point is electrostatic stress is maximum at the conductor surface and minimum at what? Sheet, okay, minimum at what? Sheet. The difference between E maximum and E minimum should be less. For that you need to reduce either E maximum or increase E minimum. So reducing E maximum is preferred. So in order to reduce the E maximum, either you need to reduce the operating voltage, but power handling capacity gets reduced. We don't prefer that. Maximize the denominator. If you maximize the denominator, you will get this condition, okay. This is the condition for most economical size of the underground cable. Now, let us try to observe how do we calculate the capacitance in case of single core cable. So how do you calculate the capacitance here? The core or the conductor radius is small r and overall radius of the cable is capital R. This sheet is at ground potential, okay. Now how do you calculate the capacitance in case of underground cable? Now here permittivity is epsilon be the permittivity. How can we calculate the capacitance? If the conductor is operating at an voltage of V, electrostatic charge is lambda. So now the capacitance is lambda by V. Unit is what? Farad. So how can we express the charge in terms of voltage? So here we got the expression for charge. Lambda value is what? V into 2 pi epsilon by ln of capital R by small r, okay. So C is lambda is V into 2 pi epsilon by ln of capital R by small r into V. V and V gets cancelled out. C is equal to 2 pi epsilon naught epsilon r by ln of capital R by small r, farad per meter. So this is how we can calculate the capacitance. The capacitance effect will be high in underground cable when compared to overhead transmission line. In overhead transmission line, this relative permittivity is 1, but in underground cable, the relative permittivity will be more. So the capacitance in case of underground cable will be more when compared to the capacitance effect in case of overhead transmission line. Why? Because one is due to nearness of the conductor, because in case of underground cable the conductors are closely spaced, and in case of underground cable relative permittivity is greater than 1, and in case of overhead transmission line the medium is air, because air is the medium in case of overhead transmission line. There the relative permittivity is 1. Okay. So you may get a question like this: why the capacitance effect will be more in case of underground cable? These are the two reasons. One is due to nearness of the conductor, and the second one is the relative permittivity of the insulating material will be greater than 1. Okay. So by using this relation, we can calculate the capacitance in case of what? Single core cable. So whenever there is a capacitance effect, we can calculate the charging current. So how do you calculate the charging current? IC is equal to V by XC. IC is equal to what? V by XC. That is V into omega into C. That is V into omega value is what? 2 pi F into C. So this is the charging current drawn by the capacitance. So charging current is directly proportional to voltage and frequency. If the supply frequency is increased, charging current increases. If the operating voltage is increased, charging current will be increased. Now, let us try to calculate the capacitance in case of 3-core cable. So if you are going for 3-core cable, there will be common insulation for the 3 cores and there will be only one sheet. So these are the 3 cores and there will be only one metallic sheet for all the 3 cores. This sheet will be at ground potential. Okay. So how do you calculate the capacitance per phase in case of 3-core cable? So first of all, there will be core to core capacitance exist. The C2 is nothing but core to core capacitance. And apart from core to core capacitance, there will be core to sheet capacitance exist. This is C1. Core to core capacitance exists as well as core to sheet capacitance also will exist. Now, how do you calculate the capacitance per phase here? So for calculation of capacitance per phase, we convert this delta connected capacitor into star equivalent. So how do you convert delta into star? So by converting the delta into star, so here you have R phase, Y phase and B phase. So whenever you convert the delta to star, so here it can be represented as 3C2 and this is 3C2. Now this is at neutral point we can say. This sheet is at what potential? Ground potential. So now this core to sheet capacitance, assuming that under balanced condition neutral potential and ground potential are same. So you can also represent this core to sheet capacitance between this conductor and neutral. This is C1 and here you have C1, here you have the C1. Now here between this neutral and core, here we need to calculate capacitance per phase. So how do you calculate the capacitance per phase now? Capacitance per phase is core to sheet capacitance plus 3 times core to core capacitance. This is the relation for calculating the capacitance per phase. This is the relation for calculation of what? Capacitance per phase. So in the question, if he has given core to sheet capacitance is 0.1 microfarad. For example, if you consider core to core capacitance is 0.3 microfarad. How do you calculate the capacitance per phase? Capacitance per phase. How do you calculate? C1 plus 3C2. C1 is how much? 0.1 plus 3 times C2, that is 0.3. This is 0.1 plus 0.9, that is 1 microfarad. 1 microfarad. This is the capacitance per phase in case of what? 3-core cable. This is how we can calculate the capacitance per phase in case of a 3-core cable. Okay. If core to core capacitance is given and core to sheet capacitance is given, we can calculate. This type of problems can be also asked in examination. So what are the losses that are going to take place in case of underground cable? Mainly there are 3 types of losses. One is core loss, dielectric loss and sheet loss. If you observe this core loss, this core loss takes place in conductor. This core loss takes place in conductor. That is nothing but I square R loss. This is a variable loss. Core loss is variable loss. The question may be asked like this: core loss is variable loss or constant loss? It is a variable loss because whenever the load changes, the conductor carrying current changes, loss gets changed. This is taking place in the conductor. Now coming to this dielectric loss. Dielectric loss takes place where? Dielectric loss takes place where? In the insulation. In the insulation material, the dielectric loss is taking place. This is a constant loss. This is constant loss. Dielectric loss is a constant loss. Okay. And this is a sheet loss. This takes place in metallic sheet. Metallic sheet. And sheet loss is constant or variable loss? This is also variable loss. This is also variable loss. And this sheet loss exists only in case of single core cable. Okay? Exists in single core cable only. Single core cable. In case of 3-core cable, sheet loss is 0. Okay? Only it will exist in case of what? Single core cable. There will not be any sheet loss taking place in case of 3-core cable. Okay. So these are some of the points that I want to keep before you from underground cables. Thank you for giving me this opportunity.